Hello and welcome to this Construct 3 tutorial on how to create a trading card game. So what you're seeing now is the end result where the player and the CPU player are being dealt 4 cards. The player here is at the bottom, that's the human player. So you can see I'm hovering my mouse over the cards. And this is the CPU player, it's the back side of the cards you're seeing here. So what else is on the screen? So the spheres here with the ladies in there, those are the heroes battling each other. The number in the yellow square here is the health of the player, and the gray square is the shield of the players. The players can have shields as well. And then here in the box below is the number of mana you have to play this turn. So what happens is the player can hover over a card, and whenever he has enough mana to play the card will highlight. The other card, which you don't have enough mana for, will stay unhighlighted and will be unclickable. So I will click this card and I will put it on the table. Like in many trading card games, whenever you play a card, it becomes disabled this first time. You need to wait one turn before you can actually play the card. However, some cards in this trading card game can do some action when playing the card just after being put on the table, as you'll see in a minute. So once I can't do anything anymore, the mana becomes 0, and here we have end turn. And once I press end turn, it's the CPU player that does a move. So what he did, he put in the slasher, you can see that here, and now it's my turn again, and automatically I've got a new card, and I've been dealt Grasp of the Damned, which is add 1 block to all the cards on the table. So I can't play this one here, but when I would do that, I would add 1 block here. So this is the block, this is the attack of the player, and you see what special ability they have. Scouts have no special abilities, you just do damage. But here the special ability of the Grasp of the Damned, for example, is adding 1 block to the cards on the table. Then there's other special abilities, of course. Here the Avenger, destroy a random card when the card is destroyed. So it's a vengeance action actually, so I will play the Avenger and we'll press enter, and then we see what happened actually. The slasher attacked my slasher. His attack value was 3, my defense value was also 3, so by what happened is the slasher attacked my slasher -3, then remove the card from the table. But as you remember, deal damage to a random player when the card is removed. So what he did is automatically he tapped the other slasher, and his defense came from 3 to 2, and then it was moved off the table. So you can see here, and that's the idea of the game here. For example, the assassin, destroy an enemy card on the table, and does that. So you can see that if that was an avengable card, for example, it would do also something whenever that card was destroyed, for example. Let's go one step further and see if I can just see some special cards. For example, here rare is the shield. Add 3 shield to the hero when played. So we're picking there, and the 3 shield is added to the player, so the enemy player should also be dealt 3 damage before going into its health, of course. So what's next? Now, not only can I play a card here and play also its special abilities, but I can also attack with the cards here on the table. So I can, for example, this one has 3 shields, and this one has 3 attack values, so I can kill off this Goliath card but you have to watch out. Before you die, deal 1 damage to the hero. So what will happen is I will attack this one with this one. This one will be removed from the table, but it's got a vengeance action, being 1 damage to the hero whenever he dies. So his shield will diminish by 1. How do we do that? We just pick it and we can choose a card. Whenever there are no more cards on the table, I can choose to attack the enemy, and then the enemy would become highlighted, and then the enemy would be dealt that damage, of course. So I will do that. You see what happens. It's dying. It attacked my my hero, -1 shield, and then it moves to the stack. So I can, for example, now play the archer, deal 1 damage to the enemy when dealing the card. So there we go, 2 left, and I can have 1 more card on the table like that. Enter. So now the Aphrodite has stacked my shield. It's down to 2 defend, and he played the one attack to the cards on the table. So what it did, whenever it started, the attack of Medusa increased by 2, of Aphrodite, increased by 2, because standard, you can see that here, it has only 1. So as playing Medusa added 1 to the attack of Aphrodite. So now she's got, let's destroy her, hitting that, and then we can go and try. This is also an interesting card. Let's play this one. Heal equal to the damage done. Whenever that card does damage, the hero will be healed that many points. So you can see that was a classic example of what we're going to come back to in a minute when we look at the code. This was a very scripted event, so whenever the player did something, a lot of actions were happening. Some cards were dealing damage, like the archer, he did damage to my player, or the cleaner, he'll do 1 damage to all enemy cards on the table. Dealt 1 damage here. You could see the card going over over the cards. So that's actually a very scripted event. I'm going to do that. Destroy a random card, and then we'll go and destroy which is the most damaging one. This one, for example. And what do we have left? We have 2 mana left. Let's go and heal some more by doing that. So you see here, deal 2, add 2 damage, add 2 health to my player. Excuse me. So here we drew 1 extra card, so we can keep on playing. Actually, I'm going to stop playing. Do remember that whenever you get your hero to 0, then the game will be over. You will be presented with a dialogue, and then the game will start over, of course. So this is basically it. And for an interface and how the game actually works, you see it's pretty complicated, and the code is also pretty complicated, but bear with me, it's actually pretty easy to understand once you get the hang of it. So you have to remember that when showing you how this works, you have to remember that it's important to let construct know the exact order in which the events need to take place. So whenever you saw that, whenever the CPU started playing cards, you saw that once there's a lot of mana, it can play a lot of cards, and all of those cards have their own abilities, and that will trigger abilities of the enemy cards if they have a vengeance, for example. So that will be quite tricky to do, to have all those events scripted. And then you'll see how that works, how this is done efficiently, and keeping them inside that sequence. So let's go, and here, this is the main layout of the game. The layout is divided into two parts. The bottom part is the part of the human player, and the top part is the part of the computer player. So each has a hero, and the hero has a health indicator. That's the yellow block, and a shield indicator, the gray one. That's what I already told you when playing the game. Now, once the health of the zero reaches zero, then the dialogue you can see here is shown. So that dialogue is just a separate layer which is shown and hidden. Let's hide this one. The brown squares just above each and below respective heroes is the mana. This one here. Each round the mana is restored and is set to equal the number of rounds played. So each round the mana increases. So the first round there will be only one mana, but the second there will be two, etc. Mana decreases by playing a card. The mana decreases by the value of the card indicated at the top right corner of the card. If a card is not playable because there's too little mana, it will become gray. The pink places are invisible and indicated here. These ones here, these are placeholders. Placeholders hold three instance variables. The player, indicating the player number, one being the human player, two being the CPU player. The type can be H for hand, T for table, and each combination of the player has 6 placeholders. That's the way it is now. These hold an ID from 0 to 5. So once a type is full, no more cards can be added. Feel free to add slots of time placeholders and stuff like that in your own game. Just add more and add more IDs. That's it actually. So this game is fully configurable. So there's no object type for every card. You can see here, if you open up the card object types, it's just a generic card and then some labels and a graphic which make up that card. And there's no card for each different type of card you saw in the game. As you saw, there are quite a lot. I think I've created 14 or something. But those 14 cards, they are configured in a definitions JSON file. And if you open up this definitions JSON file, you can see it's actually a list of all of the different cards, and each block here, like this one, defines a certain card. Here the ID is just the single ID of the card, grasp_damned. It's referenced up at some places, the ID. You can see that in a minute. And then you have 3 indicators of the behavior type, which will trigger a number of actions to do in case of that card being played with that certain behavior card. So it can also have a target. Some cards have a hero as a target, other cards have cards as a target, or all. And behavior value is, for example, this specific card will add block. The number of block he will be adding is this value. So you can easily make another card and also give it behavior type block, and then add 2, for example. You give it another title, another type. The type actually really doesn't do anything in this game, it's just there for fancy. And then there's the description with up to 3 rows. And so you can see that there's a vast number of cards. Add block will add block to the different cards on the table. Same thing for add attack, will add attack to the same cards on the table. So the behavior type vengeance is whenever the card dies, it does hero to the target, and the target in this case is the hero, and it will do 1 damage. And below the description there's also the effective value of the card, how many mana you need to play it, the defense value when dealing the card, the attack value, and then there's an image, and the image is a number which is the frame number of the image in the card. So every card visual has a frame number inside the graphic object type, which I'll show you in a minute. This is the frame number which is set whenever creating the card. So let's go further. There's the trial, which will heal itself. The archer will be the early damage, deal 1 damage to anyone playing the card. The horn will give extra mana. Here we have an avenger doing vengeance to a random card. The assassin will assassinate a certain card. The cleaner will do 1 damage to every card by calling the behavior type spread. Then the slasher is just a scout. The wizard will add 10 defense to a random card on the table. The shield will add 3 shield to the player when played, and then the tower will draw 1 extra card. So those are the different behavior types you can see here, and you'll see in a minute that actually those behavior types are reflected in the code. So when we go look further at the files here, there's also a second file called deck.json. And in deck.json, we actually say how many cards of which specific type are in my deck. So if you were to count this together, you would get 44. In this case, there are 44 cards in the game, with the division into 14 existing cards. These are the IDs of the cards that I mentioned. But feel free to add more if you go to 50 or to 60 cards. Okay, that's fine by me, but you have to make sure that this adds up to 50, to 60 then at that time, and then you have to make sure that you get this deck size here variable also up to 50, because that deck size here is used to see how many cards have to be dealt, basically. So that was kind of the main layout of the game and the data which is being used. I'll go back to this little template, and here you can see this is a template of a card. Call of the damp, whatever. I add something here. I could have added anything. So this is the effective card, which is actually this. But if you look at that card, I'll double click it. It has 2 frames, the back side and the front side. And at the front side you can see that I've baked in the value. I baked in the attack and the defend, but there's a big hole here where the graphic has to become. And here at the title, the type and the description, for example, and also the values for the attack, the defend and the mana are labels actually, and they're not here on that card. That makes it very powerful, because that way you can just define extra cards by giving it an extra graphic and defining the card in the JSON file. So what else is on that card? So the card back is actually that background, the brown background rather, here at the back. You can make them all fancy if you want to. We've got the card graphic, which is actually what's depicting the card's artwork. You can see it's ranging from 0 to 13 because there are 14 different cards, and all of those have an image reference in the JSON file. And so the rest are basically labels, and all of those things have the pin behavior, because those things are pinned actually to this card at runtime. So you can see here that it has this pin behavior, and also all the labels here will have something called original font size. Why is that? Because when we highlight the card, and the card becomes a little bit bigger. You saw that when demonstrating the game. The card becomes a little bit bigger, and that's by setting the size of that card a little bit bigger. Unfortunately, setting the size of a text is not something that's available. You have to change the font size. And that's why you'll see in a minute that there's logic here to change that font size of those little labels here, depending on the size of the card. And this is done by comparing the current font size to the original font size. So basically that's it. So the card also has a lot of instance variables, and next to that they also have the tween behavior and the move to behavior. you can see here that enlarged 1 or 0 means that indicates if the card is enlarged, yes or no. Original width and height is also to be able to enlarge and unenlarge the card. So the things in capitals here: defense, attack, behavior type, ID, value, those are things being obtained from the JSON file whenever the card is created. There's a permutation number, which is a unique number from 0 to 43, which is used by the advanced random plugin to shuffle the cards and actually identify the cards as they are shuffled. So the player instance variable holds a 1 or a 2, 1 for the human player and 2 for the enemy player. And location is a string which can be S for stack, T for table, and H for hand. Steeping indicates that the card is grayed out, and then original defense and attack is just to initialize the offense and the attack whenever playing the card, because the card could have been played earlier in the game, and we don't want to start the card off with 0 attack or a higher defense, with 0 defense rather, and a higher attack than it's supposed to have. So then this is the defense and the attack which is loaded from the JSON file, and which we did reset the defense and attack instance variables with. You'll see that in a minute in the game. So that's it. Let's go look at the code. So the code is divided into a few event sheets. Let's start with the main event sheet, which hangs here on the main layout. There's a number of variables which we'll come back to along in the game. So on start of layout, we start by hiding the game over dialog, and then we set the flag to 0 to prevent some interaction from happening when the cards are still being put on the table. So this flag will be set to 1 using a command line, a command in the command queue, and we'll come back to that, what it is in the command queue, in just a few minutes. So both players' health have to be a starting health, which is start health variable here. It's actually a constant, which is now set to 3. You can increase that, of course, if your player needs to start with a higher health. Then there's something called command queue, and we'll come back to that, but in essence we will be clearing the values here, empty it, and there's also command queue history for debugging reasons. We're also going to clear that here. So now we're going to read the card definitions, wait for it, and then load them into a JSON object. We will create a permutation table with a deck size in the advanced random plugin here, so we can shuffle the cards later on. And then we read the definitions of the deck and we load it into a dictionary. And then we can call load cards, and load cards, which we'll come back to, actually loads the 44 cards for the player 1 and for player 2 into the game. It will actually create those cards and put them onto the stack for that player. We just wait for a little while to get to the next game loop, and the cards are effectively also added to the layout, and then we will shuffle the cards. We start with current round 1 and we start the game. So there's also something called a highlighter, and a highlighter is like, for example, the blue thing surrounding the player's health whenever the player's health increases or decreases. That's called a highlighter. And here something like that, the hero health highlighter, for example, and it's used to come up and blink a little while. So here is what I told you. Here is where we're going to change the font size of the different labels. Every tick the values of the cards are updated, and also the font sizes changes with the size of the cards, because text don't have a scale. Whenever the size of the card changes, because the scale of the card changes, we will adjust the font size respective to the new size of the card in respect to its original width. So that's actually just a factor being decided. Here it's to set the font size to the original font size times however the width of the cards is divided by however the original width is. So it's a factor. If it's the same, it will return 1 times 1, it will be the original font size. If it's double as big, it will return 2 divided by 1 is times 2, and it will be the double font size. Very easy. So the interaction, basically, there's not too much interaction, as you can see. Here, whenever the mouse hovers over a card, it should be enlarged. Of course, there are several other conditions to be met. It needs to be the human player's turn. The card should not be sleeping or moving. The card should be allowed to play. The card should not be on the stack. The card should belong to the human player, and there should be nothing dragging at all. So those are the conditions which have to be met in order for the function enlarge card to be called. An enlarged card will hold reference to the card being hovered over here, and it will have a boolean value 1 for enlarge and 0 for unenlarge. So this is exactly the same, but with a negation here, not hovering over the card. So left click on the card. So when the user clicks a card, we should first check if there's a free placeholder on the table, and if there's a placeholder on the table for type T, which is the location of that card. If it's different from -1, because this function get first free placeholder will return -1 if there's no more free placeholder, then we will go and register the card, and we will play the card. So I'll come back to Q command here in a minute. So when dragging a card for attack, and we're dragging actually that the attacking arrow, which I showed you, the orange attacking arrow, we will first enlarge the card, but we check if it is an enemy card here. And the enemy card, that I forgot to show you actually, the card here, let's go here to the card template. One thing I forgot to mention here, that every card also has something, a card highlight, which is also pinned to that card. The card highlight, by default, it has the blur effect added to it, so it's kind of a bit blurred, and that's the thing, the whitish thing that you see when hovering over a player card. But for enemy cards, we enable the set color effect, which makes it effectively red. So here we will go to the main event sheet again, and then we will enlarge the card. But for enemy players, that color is set to red, so it will enlarge the card, and when enlarging the card, it will also show the highlight, in that case in red. So when the end turn button is clicked, the command should end, the player's turn should end. Left clicking on the card when dragging, dragging is set to 0, the drag card is set to 0. Then we will set the drag card to the UID when starting the drag, and we set the position of the arrow to the X and Y coordinates. And while that left mouse button is down and the card drag card is different from 0, we will set the angle and distance of the arrow to towards the X and Y position of the mouse. When the left mouse button is released and the card is being dragged, we just hide the arrow again by setting it off screen, and we can determine the card was dragged by picking it and cueing it with a hit target. We'll come back to that in a minute. Whenever we hover over the hero highlight, the hero is being hit, and we will hit the hero. So when hitting the hero, the target is -1. Come back to that in a minute. And finally reset the drag card to 0. Whenever the player is hovering over the hero highlight, we'll also have a hero highlight which is becoming white, a red halo around the player, the enemy player, so to indicate that that player is highlighted. So that's for the interaction. So now we go one step further and we go and look at what the card event sheet really does. So in the card event sheet, everything is available for card interaction or things to do with the card. I'll maybe collapse these functions a bit. there's the card uncreated, which is of course fired whenever a card is created, and whenever a card is created, we put all of the items that are in a card's container pinned to a card. That's what we do. So the highlight is the white part behind the card that makes up the highlight. It has a color effect to make it red for enemy cards. So we pin it, move to the top of the layer, set the opacity to 0, and disable the effect for the enemy cards. The back of the card is the part just after the graphic, making sure that the part isn't transparent, and this is an image point to assist in determining the correct position. So the image point, let me just show you how it works. The card itself has got everything that is to be attached to it in its container. You can see that here, and also if you double click on that card, you see here that there are a number of image points called pinpoint, card title, that's at the top left here, card type, which is in the middle here, card value, card description, card value, etc. Those are image points, and these are used here in this logic to know where to pin all of these things. So card back is image point, pinpoint, as well as card graphic. And in card graphic, if you remember, it's all animation frames. So we stop the animation and move it to the top of the layer. And then for all of the different texts, we have our different image point, and they are pinned to each different image point. And then we, when a card is created, it should be highlighted, so in full contrast. So we call highlight card. So whenever the game starts, the load cards function is called, and in essence what it does, it loops through each entry in the card definitions JSON file. So that's this JSON file here to remember. So for each entry here, it loops. Yep, and then it repeats it for the number of times in that deck. So it gets from the card definitions, it gets its ID, the ID column, which is this one, for example, grasp damped, and then goes and looks into the deck.json, and you see grasp damped, and that needs to be spawned twice. So that's what it does. It loops twice in that example. We create the object card at the spawn point, and the spawn point, if you remember, is this one here. This is where the cards are created. It's actually the stack where the cards are, and then of course this logic will happen, the uncreated logic, and then we pick the last created card. We stop the animation. So so the card itself has two animation frames as well, one for the back and one for the front. So now we get all of the items from the JSON definition, for example, the title, the three descriptions, which are separated by a new line, and then the type, and we set the original height and the original width indicated in the card. This is used to rescale the font of the text sticked onto the card. And then we go and set all of the attributes, the instance variables that take care of the logic, and we set the correct animation frame, of course, of the card. We set the correct permutation number to the loop index, and we set the player location and stack, and we add one to that loop index. So that's it, pretty simple. So then there is the deal cards function, where we get a player, a number, and an origin as a parameter. The player, of course, is a number from 1 to 2, 1 being the human player and 2 being the CPU player, and then a number of cards to be dealt and an origin. So the number of cards is passed as a parameter, and the origin here is for debugging purposes actually. So we loop through that number of cards to be dealt, and depending on the player we pop from a different deck. So the player 1 deck in this example and the player 2 deck. what we do is we just queue the commands, move the card to the player, register it at the placeholder and wake it up if the card was set to sleeping, and then we pop it from the front of the deck. That's what we do. And then we have shuffle cards, which is we shuffle the permutation table in the advanced random plugin we initialized at the start of layout, and then we shuffle the permutation table and determine the deck if the player passed as a parameter here. So player deck, we initialize the deck, and then we do a for loop from 0 to the deck size -1, and then we push back all of the cards to the correct deck from which it is then dealt. Turn card is pretty simple. We get a card number, which is a UID of a card, and we get side, which can be front or back, or front and something else in essence. So we pick the card using the UID we get from the parameter, and then if the side is front, then we set the animation frame to 1 and everything on the card to 100% opacity. Else the animation frame is set to 0 and all the things on the card are set to opacity 0. That's what happens. So then there's also two functions to highlight and then enlarge a card. Highlighting means that the code will set the contrast parameter to or either 100% contrast for highlighted cards or 30% contrast for unhighlighted cards. The fact if it needs to be highlighted or unhighlighted is the number here passed as a parameter, which can be 1 or 0. And the same principle counts here for enlarge card, where the card number enlarge parameter will tell it if it's to be enlarged 1 or 0. And then we call the tween function, where we'll size the size property of the original width times 1.2, and then here we'll reset it to its original height actually. And we use the constant size time to see how long it will take for the card to enlarge or unenlarge. So those are the functions here in the card event sheet. So then it's time for some logic. There are a few functions here in the logic event sheet. I've separated them a bit. So the start game function will start the game, and it's called just after loading everything and on start of layout. So we start by setting the current player to 1, meaning that the human player will start the game, and we reset the mana. So the current round will have been set to 1, and we set the mana to that 1. And then we deal 4 cards to every player. So that's just the deal cards function we just saw, and then we queue the commands to start the game. And then there's some helper functions here. So we get the first free placeholder for a certain player of a certain type, and that type can be H for hand, T for table, or S for stack. What we do is we loop from 1 to 6 because they're at any given place for the human player or the CPU player on the cards, on the table, or on the hand of the player. There can only be 6 placeholders in this game here. Feel free to add more placeholders if you want to. We will just pick the placeholder for the correct type we get as a parameter and the player we get as a parameter, and then we pick the ID for the loop index we're going to set here from 1 to 6. And if the assigned card instance variable is 0, means that the placeholder doesn't have a card assigned to it. And what we'll do then is we set that result variable to that ID, and we will stop the loop. And then the first free placeholder will have been returned. Is move allowed is a very simple helper function. It just checks if a move is allowed for a certain card and player combination passed as a parameter. This is done by checking if there's enough mana for that player to play that card. On a hit, hero hit allowed. This function will result 1 if a hit to a hero is allowed, and that's only so if for the cards for player 2 on the location, if there are cards in with that configuration, so there are cards on the table for the enemy player, then it's not allowed. So the result value will be set to 1 instead of the default. Will be set to 0 rather instead of the default of 1. So only in that circumstance the hit of a hero is allowed. And then there's two help functions here: get random opponent card, get random player card. So first we load the opponent, and the opponent, as always, these two functions are always in relative to the player being that's playing at that moment. So get random opponent card, if the human player is making a move, will be a random card from the CPU player, and vice versa. That's why it's called opponent card and player card, and not enemy card or human player card, for example, because it's always relative. So what we do is we set the opponent flag here. If the current player is 1, we set it to 2, otherwise 1, and then we pick here the card for opponents on the table, and then we pick a random one and we result that value. And the same thing happens here for the player card. So then there are some things that are not in a function, that's just happening in the game loop actually. So whatever the current player is 1, so and the game is started. So for the human players, we pick all the cards that are not sleeping and in a location different from the stack, and where the mana is smaller or equal than the mana of that current player. Then we will set the end turn highlight invisible, and the end turn highlight, actually, if we go look at the main layout again, this is this yellow thing that becomes flashing, that goes on flash if you don't have any moves left, because your mana is depleted. Then this thing goes flashing, and it's only in this condition. If there are no more cards here in that conditions here, then it still goes start highlighting. Then there's the little highlighters. For example, highlighters, the blue highlighters one, some health is subtracted from the players. A blue highlighter behind the health of the player will start flashing. It does that for X number of seconds, and whenever that timer hits, the highlighter is set to invisible again. And then for each card, for player 1, if the card location is in the hand and on the stack, on the table rather, and for the card locations on the table, we if each card of the human player on the table and for the CPU cards on the table, if it is sleeping, we unhighlight here, and if it is not sleeping, we only highlight it if a move is allowed. You can see that here. So that's just to automatically highlight and unhighlight the cards that can be played or not. Great. So then there's the logic of the dialogue, very simple. We haven't seen the dialogue actually because we haven't finished the game in the demonstration, but believe me, if the mana of some player, either the CPU player or the human player, hits 0, then the dialogue will be shown. And there's just showing the dialogue by showing the layer and deactivating the interaction of the main game and activating the interaction here of the dialogue, which is just a button. And when we click the button, we see start the layout, and that's it. So then we come to the tricky part of this game. I've been postponing it a bit, but I'll explain now what actually happens. So we're working actually with a command queue, and the command queue is a rather simple principle actually, where we have a command queue array. and the command queue array is empty by default, but there can be commands pushed to that array, and a command is actually a JSON string. And what happens is here, whenever the command queue has something in it, so the width is bigger than 0, and there's a flag executing to set to 0, meaning there's nothing executed, we can just safely execute the next command. So when executing the command, automatically that flag executing will be set to 1. The command will take its course, and then after everything in the command has been done, the executing flag will be set to 0 again, at which time this condition becomes true and the next command will be executed. So that's the entire principle of the game. So when nothing is executing and nothing is queued, and the CPU player is to make a move, then we queue the next move with the AI. That might also result in a next round when the CPU player finds nothing left to do, of course. So this is just the standard logic for the command queue, going to execute every single command whenever the executing flag becomes 0. But also, if the command queue appears to be 0, it means that, for example, if the human player plays, and he plays all of the cards on his hand, and the turn ends. At that time, if we were to comment this one out, nothing would happen anymore. So the computer player wouldn't start doing anything, because there's nothing more in the command, and the computer player doesn't know it's his turn. So what we do here in this functionality, we look if there's nothing left to do, and it's not actually executing something, but it's the CPU's player's turn. We just queue a command called get next AI move. And that will effectively calculate which move needs to be played next by the CPU player, and goes and queues commands in the name of the CPU player. So now what we do here is we initialize a function map, where a string is mapped to a certain function starting with the prefix fn underscore here. And all of those strings here are just constants here above. Sometimes I make constants in games to make it easier to have a code completion. For example, you see here all of those commands are constants, and we map those constants each individually to a certain function. So the command which here is execute next command is this function here. So the first thing we do is we set the semaphore flag. We set executing to 1, so this doesn't execute anymore. This starts looping, and we get the JSON from the command queue front, which is the first item in the command queue. We get that, and that command is actually a JSON string which we parse here. And then from that JSON string we get the current card, the current target, and the current command. So the current command is the thing that needs to be executed, one of these strings here above. The current card is the card that is moving, the card that's being played. And if that card is attacking another card, or a player, or a hero rather, then the current card target would also be set. And these are global variables which take care of tracking what has been set by the command. And in these functions individually here we will interpret these current targets variables to know what has to happen with those different cards. So these are actually UIDs of cards. And then we actually call that function. We call the json.getCommand.function will be called. That's being popped here from that command queue. So these individual functions will be called depending on the command here given. And then we pop from the queue, and we push it to the command history. So command history functionally doesn't do anything in the game, we just push things to it, but it can be very handy when you add some logic to the game and you use the debugger. You can go and look into the command history and see what has been executed as the last few commands. Queuing the command is very simple. This function is called everywhere in the game. We've encountered it many times already. Queue command will queue a certain command, which is one of these strings here, pertaining to a certain card, to a certain target. And then there's origin, which is also for debugging purposes. So whenever we check in the command queue over the command history, we can also check the origins to have some kind of tracing where this began. And then we have the onMove to arrived, which is actually a very important event here. For those functions that end up starting the movement of a card, the execution semaphore flag is not reset. Instead, this reset here when the card has started moving also arrive at its place. And then we set the executing flag to 0. That prevents multiple cards from moving at the same time, because in some cases we might check if a card is still moving. It might be very difficult for the human player to interpret what the animal player is actually doing. Sometimes it's important to see the movement of the card of the enemy player to see, okay, he has just attacked that card, that card has depleted his defense and is now moved to the stack. If we weren't to do that, those two things would happen almost simultaneously, and especially if there is a lot of moves to be made by a CPU player, then it would be very confusing for the human player what he actually did. So that's why we queue them. Every card movement has been queued, and the next card movement will only be executed when the prior card movement has happened, by checking this execution flag and setting it to 0 whenever the card arrives. So that's very important. So then the last thing we need to see here, or the last but one thing, is the different functions. And the different functions, there are quite some functions here because there can be many commands queued. Collapse them a bit so I can explain them a little bit to you. Okay. So the move card to hand function means moving a card by picking the current card and picking a free placeholder. Those are things we already saw. But we also set the defense to the original offense and attack. So we make sure it's not sleeping, and we move the card to the placeholder's X and Y coordinate. For the commands, for the cards .player 2 means the CPU player, we also turn the card around. And very important, as a last step, we set executing to 0. Then move card to table. Then what we do is we pick the current card, we move to the label, we enlarge the card, we turn the card for enemy players to the front in this time, and we stop executing. Move card to stack, moves the card away, it's just moving the card to the spawn point. So very important two functions here, register and unregister placeholder. Whenever a card starts moving away from a placeholder, the unregistered card at placeholder is called, and whenever it arrives at a placeholder, the registered card at placeholder is called. And that's very important because whenever a card is registered, the placeholder's assigned card property will, or instance variable, will be set to the UID of the card which is moving, and the location of the card will be set to the placeholder type. Vice versa as well, if the card is unregistered, the card of the placeholder which it is assigned to will be reset here, and the card location is also reset. That's important because there's a lot of logic checking the assigned cards of placeholders, and also a lot of logic checking the location of a certain card. So it's important that these register and unregister functions are called at the appropriate places. So if you go and change the rules of the game or extend the game, make sure that the cards are registered and unregistered at the correct places. So sleep card will put the card to sleep, so we'll set the sleeping here to 1 and unenlarge a card. Very simple. Wake up card does the opposite. It will set sleeping to 0 and that will highlight the card again automatically. Play card means playing a card from the player's hand. So the command function is called when playing a card from the hand to the table. So first we pick the card to be played and we retain the value, behavior type, target and value for later use. That's what we do here, and we store these values in local variables. The mana is subtracted from the correct player, and we also determine who is the opponent in this situation, because these functions of course are called both for human players and for CPU players. So these functions are independent of that, the current underscore player instance variable keeps track of the current player which is doing the thing here, and then we just say if the current player equals 1, then the opponent is 2, and vice versa. And then we have to check the behavior type of the different cards, because depending on the behavior type, other things also needs to happen. So behavior type, if it is mana, then mana will be added to the player's mana whenever the game is played. So instead of subtracting the mana, we will add it. So we will add the behavior value of the card plus the card value, because by default the card value will be subtracted from the mana, so we compensate by adding it back to the mana and also adding the behavior value. So that's what we do here. The behavior type assassin will pick a random opponent card, move it to attack it, and remove the card from the table. And please notice, it's very important that whenever something happens here, it's not done automatically and not done immediately. Instead, all of these things are added to the queue, and that is very important. Nothing happens immediately, but everything happens by means of the queue. So if there is a result of playing the card, it should be queued as a command, and that's what's happening here. We command move in, command remove from table. That's what happens. So whenever the behavior type is add block or add attack, we will for each card which is on the table, we will move into that card, and depending on the behavior value, the add block or add defense functions are called. So early damage will move into the attack, and here attack the hero. So that's what we do here. Withdraw an extra card. Defense on the target hero, for that situation a shield is added to the hero. Otherwise we get a random player card, and if the card differs from -1, meaning there is a card found, we move in and we add defense to that player, but we do that behavior value times, because we can add 1 or 2 or 3 times the defense, because defense doesn't take a parameter, it just adds 1 to the defense, and if there's the card definition says you need to add 2 to that defense, that this command Q should happen twice, and so that's why it repeats behavior types. Behavior type spread just loops through every card, moves into that card, deals some damage, and then we call the handle target function, which will come back in a minute, which will handle what needs to happen to the target card whenever the damage has been dealt. So that's a very important function, actually, play card. Next round, when calling next round, the round is increased and the player is resets, and the human player again. Add 1 to current round, set player 1 to 1, and then set the mana. If there aren't already 6 cards on the table, deal an extra card. That's not correct. Whenever there are not already 6 cards on the human hand, of course, or on the hand of the current player, then we deal an extra card. And we reset the sleeping flag for all of the cards which are already on the table. Then we end the turn by checking if there is some cards on the hand of the current player, and dealing a card, and set the current player to 2, so the AI functionality will automatically fire, what I told you earlier. So hit target means that the current card is picked and the mana is subtracted from the player mana. That's what happens here. We move in for the attack, we damage the player, but we do that attack times, because a card can have a higher value than 1, and because again damage target only damages for 1 value, So we need to attack that the card attack times. So that's what we do here. But if the behavior type is heal, then the player should be healed. We add 1 to the player health for player 1 or player 2 health for player 2. And then we start the highlighter for the health of the player, and the highlighter will blink, and then the timer will shut it off. And then we call handle target again, move out from the attack and sleep the card, because the card can only be executed once. So handle target here, what does it do? We pick the card which is the current target, and if that card has no more defense left, it should be moved to the stack. But if the current card has vengeance, the damage should be dealt to the hero or a random card depending on that target. So when the card behavior type equals vengeance and the target equals card, we pick a random player card, and if it is found, meaning a difference from -1, we attack that card. Else we attack the hero which has target -2, which is not a card reference but a constant -2. And finally we unregister the card and move it back to the stack. So if the card defense is higher than 0, we will just there's some defense left in that case, so we unhighlight it and we just unlarge the card and we set executing to 0. So move attack in will just move a card to a certain X and Y position, and that X and Y position can be either -1 for the enemy hero, -2 for the own hero, or else X and Y coordinate of a current target actually. So that's how the X and Y coordinates or local variables are determined. And we set original X and Y for the card, and that's important because whenever we move out of the attack, we'll see in a minute, we need to make that card move to the original X and Y position. So we retain that original X and Y position, and we move the card to the target. And what we see here, we move back by moving to the original X and Y coordinate. Get next AI move will get the moves from Q next AI move, which is in the last event sheet I need to explain here. If it returns 1, then it will not execute this command next round, but if it returns 0, meaning I cannot find any AI move anymore, then we will go to the next round. And then there's some little functions that either add attack to a card, add defense to a card, or deal some damage. And when dealing some damage to a target, it can be -1 for the enemy hero or -2 for the own hero here. And then we need to see some things here. If there is shield, we need to subtract from the shield, else we need to subtract from the health, and then again we need to check, make the highlighters blink again. And then here is the game over check. If the player health 2 goes to 0, then there is a game over dialogue with success 1, meaning you won the game, else success 0 here when the enemy player when the human player becomes 0 or less than 0, then we show the game over dialogue with saying you lost. Same thing happens here for the own hero, and then we go and add subtract from a defense here. We use the max function here to not go below 0. Remove from the table, we'll pick the current card, unregister the card at the player at the placeholder, and move the card to the stack by calling those or by queuing those commands. And start game is very simple. We set the flag and we stop executing. So those are all the functions. You know that you will have to extend if you go and find new behavior types for certain targets and you add them. You should also here, for example, extend play card or hit target to or handle target to be able to execute the result of that new behavior type. Last thing I want to show you here is the AI, which is a very simple function actually, and it's a very dumb AI. Feel free to add more logic to it if you wish to, but of course it will be the own rules for your own game, so I've deliberately kept this very simple. This function will result 1 or a 0. It will only result 1 if an AI move is found and has been queued to the command queue. So if the player 2 mana is bigger than 0, the default for the result value is 0. So we only set it to 1 whenever we find a command here and here. So if it's bigger than 0, if it's smaller or equal than 0, then it will not execute and it will stay 0, of course, the result. We prefer attacking first, so we pick a non-sleeping card on the table that's within the current mana range. We save the card for later. And if there is no card to be found in that situation, no viable card on the table, it checks if there is a card on hand. And if there is a card on hand, we just unregister that as a placeholder and we play that card as a CPU player. And the result value becomes 1 because we have effectively queued the command. So if that temp card here we set here is different from 0, so we found a card to play with, we pick a random target card at that moment. At that moment just random, but feel free to add some extra logic to make sure, for example, the best card is destroyed first, for example. Else, if there are no more cards found in this logic, that means there's no more cards on the table and we can easily hit the hero, and then we set the temp card to -1 because that's like a constant denoting the hero. And if these are different from 0, these two, temp card and temp target, we can just hit the target and we queue a command. That's it. That's how you create a trading card game. So I hope you liked it. As always, please like and subscribe. And I will leave a link in the description of the video to the Sierra store where you can get this full template. Thank you for watching.